This conference will
Today's
now be
speaker
recorded.
with us. So please, we will start our session at sharp 11 a.m. All the participants are requested kindly mute your mic.
Ma'am, please start.
Many participants already joined. Good morning all. I am Dr. Kalpana Rai, convener and HOD CSC. On behalf of Department of Computer Science and Engineering, welcome you all in this one-week faculty development program on information and cyber security and blockchain technology are organized by Rajiv Gandhi Praudhyogiki Vishwavidyalaya under TechUp 3 scheme in association with Department of Computer Science and Engineering, SIRTS Bhopal. Our today's speaker is Engineer Praveen Kumar sir. He is a founder, CEO, and engineering head at Ekagga Technology and Services Private Limited, Bangalore. His today's topic is IoT platform and security over devices. He has a very vast experience in industry. He has more than 15 years of development experience. He is a technical leader, programmer, innovator, and mentor. His work profile includes the hiring, team management, product roadmap, planning, and IoT architecture. He also have commands over many languages. The list is very long. I just mentioned here like Linux, MySQL, MQTT, TCP, socket programming, and so on. He also done various certification courses like Scrum Alliance certified. He is a certified for that. Scrum Master, Good Agile, Scrum Alliance certified product owner, Good Agile. So his profile is very vast, and he done so many projects on IoT and IoT based architecture. So once again, I request our today's respected speaker, Engineer Praveen Kumar sir. Sir, please, you can start your session.
Thank you. I think you need to give me presenter rights.
Yeah, sir. We are providing you the.
Thank you.
So now you can share your screen.
Can you see my slide?
Sir, you can now share your screen. Yes, sir.
Yes. Can you see my slides?
Just it's loading. Yes, sir. We can.
Okay. So let me know once you start saying it properly. Is it visible?
Yes, sir.
Okay. So very quickly, I will just summarize that how I plan it. So very first 15 minutes, I will be talking about the overview on the IoT platform. 15 minutes, we will take a quick demonstration and we will show you that how can you build one small device and then you can ingest data to the platform. How can you simulate it? And then next 1 hour, basically we will be talking more about the security aspects. So in general, I will cover up the overall security aspects, but cover up more details in the device side. We'll also do some hands-on and try to show you guys that how, let's say, some of your basic knowledge which you have used, or let's say which you have acquired in your other networking and others paper, will help you to write an IoT application. And hope, I think you people can collect the question and then we can have a follow-up session of 30 minutes towards the end, where like I can go through the specific questions or let's say anything which is in common people are trying to ask. Okay. So Internet of Things, right? So basically, Internet of Things is, as you know, that is nothing but it's a connectivity where it is enabling all of the embedded devices as well as the normal devices to communicate and then exchange data. So the prime goal of Internet of Things is to basically enable the data movement. Of course, there are various other angles of the IoT where there is a analytics and other pieces comes into that also as a part of IoT, but that we are not going to cover up. So think about that IoT is a network of physical devices which basically enables you to connect, exchange data. Okay, and very quick summary of guys, can you go on mute the noise? Okay.
हेलो एग्जाम होगा बच्ची का
Hello. Okay, so I'm just continuing. So this Internet of Things is coined by Calvin Estron and at PNG in 1999, and by 2020, if you see, it has crossed. This is little old data. It has crossed close to 50 billion subjects, and then it is also estimated that the market is reaching some place 7 to 13 trillions of businesses by this year. So there is a huge amount of IoT application which are coming up. So what we'll do, like we will have a very small video. We'll just go through it and then I will continue.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications.
So what you have seen, that very important aspects that these devices should talk to the, let's say, platform in a more secure way. So security is one of the prime concern. Otherwise, let's say anyone can exchange the data over the network, right? So means in each of the IoT implementation and the application, security is one of the prime concern.
That address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, The sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm.
Yeah. So see, what is important over here in this small video which I was trying to mention through this demonstration, that when the vehicle is talking to the platform and then platform is talking to the vehicle, both need to be securely communicated. You know that right nowadays there is a activities going on the autonomous driving, right? So through the platform you can send a command to, let's say, take a break or take a left turn and right turn. And if this is not securely done, and if, let's say, somebody hacks your car, or let's say this communication, what will happen, that you may end up into some of the accidents, right? So it is very, very critical to have like secure communication. So we will talk about the communication part also in more in details.
Confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
Okay, so very important point is the security part of it. So let's move into it and then talk about, let's say, different segments into it. So if you look at IoT, so of course one of the important aspects is the devices. So the devices is of various nature and various industries. So it is called like vertical. So for example, there could be devices coming from the industrial IoT, where, let's say, you're trying to automate some, let's say, refinery, some steel plant, or it could be car manufacturing plant and so on. Then the next another use is on the smart home. And then of course, like car we are showing as a automotive, where like this is. So one piece is the things or the devices. Then we have the IoT gateway. So IoT gateway is nothing but the control unit which basically bridges between the IoT platform and the devices. So most of cases, if you see, these are in certain cases is embedded into the device itself. In certain cases there is a separate device, we call them as IoT gateway. And then we have IoT platform. So IoT platform, you must have seen that I'm showing a secure and the non-secure. So what I'm trying to say, that there's a couple of activities which are open, where like as a end user you can go and browse it, but there's a lot of information that is is secured, and then you will only be able to access if you are authorized for it. On the right hand side, there's a large application. For example, if you have developed your IoT application, you'd like to monetize by help of hello. Is it clear? Okay. Yeah. So right hand side is the enterprise applications, where like you should able to monetize it. You should able to integrate with the ERP system. You should able to integrate with the billing system, CRM system, and so on. So if you look at the challenges are every places. For example, if the data which is flowing from a things to the IoT edge or the gateway, this is typically done in a local vicinity with using a protocol like Zigbee, Bluetooth, Wi-Fi, G-Wave, RF, right? And if it is not secure, if it is not secured, what happened that uh, the chances that the data is stealed, or let's say somebody can emit a wrong data to the IoT. So then coming back to the gateway, so gateway to the platform is this is uh, uh, this is a long range communication. I think somebody has opened their mic. Could you go on mute? Reason is that it is echoing.
All the participants are requested, please unmute your mic. Kindly unmute your mic.
Sir, now you can unmute yourself. Sir, you can unmute yourself.
Yeah.
Yes, sir,
So
please.
yeah, so I was talking about that IoT gateway to the platform. There is a long range communication where um, this need to be again secure. Similarly, when you do third party integration, that is another communication channel that need to be secured. Then the API through which you may be writing mobile application or the dashboard. So these are like different security requirement. Anyway, we'll discuss more in details. So if you look at the IoT platform, so how this IoT platform, security is the core of the IoT platform. Without security, none of the IoT platform or none of the IoT solutions can be built. So that's the reason if you see the bottommost is the security layer, and then there's a different components are shown, like there is a connected devices, there is a IoT connectivity, there is a gateways, and then different layers. I will just demonstrate you with a small example. Let's look at if we are trying to integrate a smart plug onto an IoT platform, what is required? So very first step, user will come to the platform, they will register themselves, and after registering, let's say you will do a device registration, the second step, and after doing device registrations, um, the device can start sending data to the platform using a well-defined API or endpoint. If you see that I'm just showing the data, how the data is flowing. It is flowing through IoT gateway, and then through gateway it is going using connectivity management, coming to the data management, and finally it basically leads to the application of visualization tool. So user can consume API and can display it on the mobile app. Okay, so pretty much if you see, user will also able to turn the devices on and off. So this is the scenario or the flow in the IoT device. Similarly, like there is a data from the mobile device is coming, and then finally the control is flowing. If you see, through the device management, control has come to IoT gateway, and then finally it is delivered to the devices, and finally the devices basically turns. So see, I'm saying like this is very quick overview of the IoT platform. In case of IoT application, there are various use cases. For example, there is a smart home, wearables, connected car, industrial IoT, smart cities. There is a huge opportunity in the agriculture is coming up where like people are trying to automate things with help of IoT. Smart retails already has seen a couple of IoT implementation where you need to just walk away. Uh, if you look at the Amazon, one of the implementation, they don't have a billing counter. So once you buy stuff, you just go out and then the required amount will be deducted from your ballot, right? So in IoT in healthcare is another important area, energy management and so on. So what I will do, I will make a pause here, and then I will show you a quick a demonstration of the IoT, how the IoT platform looks. But before that, I think we can also cover up the key components. So devices is one of the core of the IoT things. So of course, sensor is the sensing equipments which basically senses the data. Then with help of the miniature computer, you send that data to the platform. You use some connectivity. Um, you use the mobile devices or let's say the platform to view it, and then similarly like you have a cloud where you should store all of this data. So this is pretty much same thing. I think these are in the picture. I'm just walking through. Okay. So I just want to focus all of your attention into this slide, and this slide basically summarizes everything of IoT. So very first part of IoT is the identification. So you need a sensor, but you need to identify that to whom this sensor belongs. Hello. Yeah. So, so the next thing is the sensing. So the sensors should perform a specific task of sensing, and with help of the certain communication channel, you should basically send it so that there should be some computation or the data processing should able to happen on top of it, and then finally you can provide a services. Of course, so this is like key integral part of the IoT elements. Okay, so with this, I'm just pausing it here. I will just open our platform very quickly. We call this as a Avikshit IoT. So let me just log in it here. Okay, so what you can see here, once you sign into this IoT platform, you see like it is showing you the total number of devices, how many of them are online, how many of them are offline, what are the alerts has happened. So here is the list of devices that can be viewed. Okay, so here are the list of devices which can be seen over here. What I will do, I will try to create one device, and then we'll show you this security aspect of this, and then we can also simulate it because we don't have the real device. I will use my laptop to basically simulate the same thing. Okay, so if you look at here, we have something called key management. So as one of the security aspect, any device which is talking to platform, you need a new key in order to talk to it. So let's say I have generated a new key. If you see there is a key which got generated right now, like this is the key with it's a 10.6. It's got generated right at this point of time. Now there is a device management we have. So there are different type of devices. If you see, we have already created. What we'll do, like we will go and create a new device type. So let's, for example, for today's demonstration, we are creating this device. We are calling this as a um, let's 1 second. Yeah. So we can just say cert device. Probably we can say cert device. Okay, let's say this is the device name, and then I'm just bringing this as a smart plug. We have created the key, so we need to select a key. If you are not selecting a key, you can't create a specific device. So let's say I am giving an external serial number. So just think like you have your mobile phone. So you have an IME number, right, which is uniquely identifying your device. Similarly, when you implement something on IoT, there is a unique identification. So with help of that, you can create a device. So now when you do it, what has happened? You got a new device created here. If you see, the third device is created. So now I can just means you can easily relate. When you have your mobile phone, you have various parameters uh, embedded into your mobile phone. For example, who is the user of this mobile, right? And then what are the, let's say, a different list of sensors which is there in your mobile list. So just think like we are creating a small entries here into this third device. We are saying a new entity type. For example, I'm just calling this as a weather controller, which can give us the temperature. So let's I've created one of this. One second. So I created one entity. This is nothing but just think like this is a logical grouping, and then there is attributes. So let's assume like there is a temperature. Uh, Again, this is a type, and then this default is 0. We have something called degree. See, is a unit of it, and then I have created this as well. So what you will see that I have created a new device, which is we are calling as third device, and then we have one entity, and then we have an attributes. So temperature. Now think like my laptop is working like a device which is sending the temperature every 1 minute. So in order to code this, it is very simple. You can just go here. Uh, so you can just and all of the details are kept over here. So I'm not going through the details. You also have a sample code which you should, if you want, you should able to refer it. Means this is the code. So I have already taken it. I'm saying like I can just. Okay. So coming on this platform, if you go to this device in this tree view, you should able to see the newly added device. You see this is the newly added device, and here is the ID. So this device is known with an ID 198, and the attributes what we have added, which is temperature, is 133. So what we'll do in our same demo, means this specific code, we will just modify this numbers like 198 and 133. So let's say, and what if you see right now, if you see the data here is null. So we can just run this demo as demo, and the moment it send a data, you see the script has started. It has just generated a temperature which is a random number 17. And if you just look at here, you see this device, and in this device this 17 data has appeared. But same time, let me go through and show you the tree view also. So here is the 17 data has come. Okay, so if you just go here, there is a visualization by which you should also able to see this specific device by creating a widget. You can add a widget. Widgets are nothing but, let's say, demonstration of the same specific attributes. So if you see this attributes, you will start seeing that data. So you see 17 data has come, and after a 1 minute it will again generate another random number. See, it has generated 35. So if you just refresh it, you see the next data has appeared, right? So pretty much if you see any of the, so this is just a simulation which I have done on my laptop, but very similar way. uh, you can have your devices communicating that data back to the platform. So this is just to give you overview of it. I'm saying now we will go to the security aspect of the part. So with this, I am also finished the second part, which was like demonstration part of it. Let me go through the platform now. Okay, so I will skip all of these slides. So we will just directly, I think I have already covered this one very quickly, not in a detail, but let's come back to this one. Okay. Okay, so now the next section, next 1 hours, we will be more talking about the security aspect of it, that what are the challenges we see. Okay, so if you look at the IoT platform, typically looks this way. So at the bottom most is nothing but things. If you see, this is known as smart things. So if you see here, right? So Internet of Things, as you know that. So the below part is the thing. So it could be your smart camera, it could be door, it could be sensor, and so at center there is a IoT gateway. So this IoT gateway is typically mostly Linux box or embedded devices. They are also Android in certain cases when you are using set-top box or smart TVs or so. But most other cases it is a Linux box. Okay. Then the central unit is the core of the IoT platform. This is known as the data ingestion, where like the data from the IoT gateway is flowing, right, and then the data is stored into the various DB, for example, MongoDBs, or let's say if you have video or certain large object data, that is also stored into the S3 object data store. Okay. Left hand side you can see third party integration. So there could be large enterprise who already have their billing or CRM or various other systems, right? So that system integration is another part of important thing in the IoT, where they should be integrated into the platform. So now if you look at like what are the key area where the security is required, right? So see, one thing is communication is very important. If you look at the gateway, when it is talking to a smart plug, that communication need to be secured. Okay. So I will just show you. Let me. Okay. Uh, So if you see, like I'm just demonstrating a small piece of it. For example, any IoT gateway, they are no mostly talking to the cloud with help of a MQTT channel, and then through gateway we have a socket, TCP socket created. Like we have opened a socket, and through socket we are talking, right? So see, in communication like this end need to be, the green line need to be secured, and same time the orange line need to be secured. Of course router is being used through which this guys all are connected, but as a depiction if you see, this both need to be secured, right? So security at every communication is very important in IoT, but security at the devices are also important, that we will come up in a minute. But let me go through this once again. Yeah. So as we discuss over here, that all of the dotted or let's say the strong uh, connects, if you see, all of these are very important aspect of it. Okay, so let me now move to the security. So see, why security is very hard in IoT. The reason is that you want that devices should able to communicate and take decision on behalf of you. If you look at your typical laptop system, your mobile system, and most of your system, it is operated by humans. So human is sitting, they are turning it on. They, if there is a security updates, they are sitting over there to update it or upgrade it, right? But the challenges are manifold when you want like things should be automated. For example, you want that things should be connect, every object should connect, they should exchange data, you should comfortably like when you are going to your home, your AC temperature should be set, your geyser should be on, and like various such parameters should happen, right? But same time, it is challenging, because there is a lot of sensitive data which these objects are exchanging, right? So sensitive data is basically not for public, so it need to be very securely transferred or used across the systems, right? So all of the challenges of security, for example, confidentiality, integrity, and availability is a key concern over the IoT. Let's look at the major challenges. What happened is happening, the every day you're adding a new buckets into the device list. For example, earlier, like, let's say, curtain were not smart, means like you have to manually operate it, but nowadays people are trying out to use the curtain where, like, you should able to control that, right? Similarly, like, you have a motion sensor deployed in your home in order to, like, alert you if some abnormality is happening. You also have ambient sensors and various such sensors, right? So more and more devices are being added, and then they are collecting a huge amount of data, more devices, and then the security is very important in that aspect. So let's discuss, spend some time over here, and then in the next slide I will talk about the security into the different layers of it. So first of all, what you need to understand that IoT is basically enabling M to M, so machine to machine communication, or let's say device to device communication, right? Where what is important is that people should securely exchange the data, right? So this slide we will revisit, but let's come back to the security layers which is required. So the different security which is required in the IoT is, one of first is the physical security. So what we are talking about, the physical security. For example, if you have your devices can be stolen, can be breached, can be means tampering can be done, right? Similarly, like the platform where you have deployed, that need to be also physically secured, in the sense, typically most of us is using now Amazon or Google or similar cloud, but the case is not the same for everybody. For example, if you look at industries, especially like the large factories or industrial use case, they have their own data centers, they have their own server installed in their premises, so that need to be secure first. Then we are talking about the network security, the communication which is happening need to be secured. Then we have access, for example, who is authorized to use the system, right? How will make it more strong, and like, strengthen it, so that it is easy for guys to use, but same time it is very difficult for guys, unauthorized guys, to access it. The application security could be, you may be writing various application, and all of these applications need to be securely talking to it. You need to provide a mechanism for it. And of course, the device security we will discuss in more details. We will also show some demonstration and that part of it. Okay. So as we discussed, data center, right? So mostly the data centers, we are using a cloud based companies, and then cloud based company is responsible for like taking the physical layer security. Also for the large organization, let's look at your institute might have their own servers in the campus where you may be deploying some of the IoT platform solution, right? So all of these challenges are taken care into these two places. Then we have network security. So most, not, I will not say most, I'm saying all of the communication certainly goes over the HTTPS, so that like, it is secure in terms of data which is going over the transfer. Also there is a concept which is used called DMZ. I'm not sure like how many of you have heard about it, but it is actually demilitarized zone. So what used to happen, that everything what you have on the cloud is not accessible by end user. So only the public interfacing systems were kept open, and then rest all were kept inside your more stricter area. And only there is a authorized rules due to which the front facing system should able to access it. So let's say in case of attack, if there is a attack happened and you compromised, let's say your server is compromised, at least the data and other parts are not compromised in the sense. So that's the pretty much approach being used everywhere, and this terms is known as DMG. So most of the cloud companies, SaaS-based companies, or if you look at the telcos like Airtel and others, they all uses a DMG kind of architecture where they do a clear separation of databases, connection servers, and operation. So only the authorized specific communication can pass to the next layer. Otherwise, they all will be ended in the public interface thing. Also, like there is a strong encryption which is being used in most of these cases to exchange the data. So let's move on into access security, right? So, for example, let's say if you bought one of the solution, or let's say you develop one of the solution, right? You certainly want to make it more secure in terms of accessibility. You don't want that unauthorized users to be able to use it, right? So certificates are basically being used to log in. Means non-certificate based login is prohibited, and only those who are having certificates they can log into it. There is also SSH and the two-factor authentication kind of approach are being used, where you don't key in your code directly, but you should use the SSH key to log into a server. Similarly, like you use two-factor authentication, so it's not only keying the password, but you will also get an OTP, or let's say a certain other way by which you generate the numbers, and then you should do it. Then there is also jumping systems, or like jump boxes are being used. So what are these jump servers, right? So these jump servers are like, they don't give you the direct access to the server. You need to first go to the jump server, and through the jump server only the other services are, or let's say other accesses are allowed. So let's come back to the application security. I'm saying in the application security, there's a lot of consideration. For example, one of them is the stateless API. You don't create something which is state-based. Otherwise, like somebody may hack your, they do some session hijacking, and then they can actually validate that they are the right user of the session, and then you keep giving him the data on top of it. There is also SQL injection that need to be prohibited. For example, all the old legacy system, there are chances that you should able to do SQL injection kind of thing. So mostly people are moving away from the SQL, or like they are completely segregating the databases. So this is the another area. Domain-based critical management, in the sense like some critical activity will only be allowed through a certain IPs. So there is a white listing of IPs happened, and then through that IP, for example, if you want to delete certain devices, right, you will not be allowed unless like you are logging through a valid IP. There is a whitelisting of the IP from your location, and then only using that you should be able to do it. So there's like limiting, or let's say narrowing down the access certainly help to perform application security. Two-factor authentication is another activity anyway. Okay, so now we will discuss a bit more about the device architecture and the security. Okay, so we will discuss about the device architecture. We will also look at some of the security challenges in devices. Then we will talk about some of the communication security, how should we bring in. Then we will also talk about the device architecture security, in the sense like there's a Linux container, and then the Linux control group, and then some of these concept which is being used nowadays into the devices to make it more robust in nature, and same time enabling the end user to also do certain activity on the devices. Okay, so let's move on. So typically, if you see, I'm saying like this is just a reference, don't get confused that this is the only device architecture. I'm saying there are various device architecture exist, but yeah, Linux is one of the major devices stakeholder, where some flavor of Linux could be embedded Linux, could be BusyBox, could be like some Ubuntu, or could be various flavor of Linux. So or Linux Unix flavors. So that's the reason I have chosen it. And then there are different. So typically, if you see, the gateways will certainly have some additional communication modules, which is shown over here. If you see the below part, we have written RF, BLE, Wi-Fi, G-Wave, Zigbee. So reason is that the gateway need to communicate with the device, and device, or let's say specific sensor, and sensor may be using a technology which is G-Wave, right? So that support is required. And then that communication also need to be secured. Very basic approach what people are taking is to at least use some symmetric key encryption, where like you have a key exchange, and through that only you send the information. And then if you are the right user, or if is the coming from the right guy, then only the data is accepted, otherwise the data will be dropped at the edge level itself. So there are certain things which I would like to highlight here. I'm saying, if you see that these are like different containers which I've shown. I'm saying, just think in your normal Linux concept. These are like different services or the processes which are running. Okay. Now I have a means just a question to all of you. So what is the challenge over here? Let's say if you have a house, and then you are staying, and then you got a new friend to stay with, right? And then that friend is having full access to your house. Let's say there are chances, if he's a good friend, no issue, but if he's a bad friend, or let's say bad guy, then he may steal some of your stuff. He may do some damage to your home, right? So very similar thing, if you see, there's a good process and versus bad process, right? A process which is allowed to be executed in the system, if he gets the full access to the system, he can consume more CPU, and then actual needed application may not get that. Similarly, like he may consume more RAM, he may consume more disk, or he may make the system unusable, right? So there are a lot of security aspects into that. And then that's the reason the containerization is a very important consideration into the Linux boxes. Say you want, like, let's say new people should come into your let's say shop, for example, you have opened him, but he will have a very restricted access. He will not be allowed to go and sit and look at the counter. He can see the products and he can go. Very similarly, the similar concepts are being implemented. If the Docker is one of the popular adaptation in the like the data center side. Very similarly, like the Linux containers are very much popular in the embedded side as well. So if you look at, I'm just for a representation I have put here, there's the application, right? There's a user application. So see, some of this RF stack, device management, cloud communication, streaming, this may be your application which you have developed, and you have a control that they are written in a good means in a good notion, that they should do best use of the system, right? But the user application is certainly a challenging one. Reason is that user is not very much concerned that what is the capability, or so let's say the device capability is left out, which I should use it, right? So means keeping this slide in mind, I think there's a lot of improvements, or let's say a lot of activities are done. So I will just want to bring here the reference of your Android phone, which you all of you are using, right? So the Android phone, when you download a new APK or application, that application runs into a sandbox, in the sense like they will not be able to exchange data of the other application. And similar time, if they consume more memory, the system will kill it, or they may go out of memory concept, right? So all of those best practices, this is also called AC Linux policies. So AC Linux policies, nothing but if you look at typical standard Linux system, if those who are having sudo rights can do everything in the system, right? But there is the next level of grouping is done, where like even if you are sudo, you are only allowed to, let's say, read two folders. What will happen if you go try to read third folder? You will not be allowed. So those all are the, let's say, practices which is being used. So the challenges over here is of course, I can just quote one of the reference when we were doing a development in 2016, when we were designing one device, and then we connected that device on an open IP, in the sense a static IP, and then somehow the password was not updated, in the sense we had default Ubuntu image, and then password user was Ubuntu, and the login password was Ubuntu as well. What happened that, and then the team from US were supposed to access the same devices, and so that's the reason we kept it open, and somehow I forget to make the password more harder. So what we have seen that when Monday I visited the office, and then I was just looking to that Ubuntu system and trying to run certain commands. I just ran a history command, and I was amazed. I saw that various different commands were executed, and then I just asked my counterpartner in the US that, hey, have you run this, have you executed these commands? He said, no, I was off, I have not used the system. Then I, just debug it, and then figure out that there is a bot running into that system. What they have done, they have got, let's say, million emails, and then they have kept it one small script running where, like, it was just sending a mail to those emails saying that your password is compromised. Here is the new interface. Here is the URL to reset the password. So it's a bank. There's a Wells Fargo bank kind of thing. I mean, the different bank thing they were showing. So what was the thing that they have also hacked the other machine? When you click the link, it is also going to another system which is not, which is again from India. So I'm saying, like, if you are not securing your device, see, the next device will be built was an automotive device. So a device is there in a truck, and then it is going from, let's say, Delhi to Bengal to Punjab to various places, right? And nobody is physically looking at what's happening over there. So you need to be keep watching also that what's happening, and then you have to really look at that non-authorized use of device should not happen. So anyway, I think it's a various approaches which are being taken in improving it, but one of them is certainly like limiting the application or processes to only use the resources which is granted to them. Of course, there is a huge challenges also in case of OTA, over the air upgrade, and the OS upgrade. Reason is that it need to be securely done. Otherwise, the devices may go into different mode, which will not work. So okay, so let me move into the next slide. So okay, so just look at, I'm saying, like, very small smart home security solution I'm just showing you. Though you are calling it secure, but most of the cameras today which is deployed in your home is on a risk that these are exposed to the manufacturer's cloud, as well as also there is a chances of hacking them. Okay. So some of the rule of thumb I can just tell you. For example, what we are trying to do here, there is a 4 camera installed in a home, and that camera is basically uh, connected to a connected over a Wi-Fi, or let's say LTE of the home, and then through that it is exchanging the data to the cloud. Okay. Now, if somebody locally know the all of the credentials and the details about these IP, or let's say if this is open, you see most of camera there is a, in a local network there is a open IP. If you put the IP and the port number, you will able to see the video stream, right? Which may be very confidential. So that is very important aspect that you should look at and make it more harder in terms of breaking it. Of course, security cannot be said that it's 100%. It is always a choice. It's always a you can make it more harder, right? So if you look at this picture over here, so all the red angles, means red lines, need to be secured in the communication. For example, Wi-Fi need to be secured, the Wi-Fi to the cloud, this data is going, that need to be secured. From the cloud, when you're getting the data to the application, that need to be secured, right? So all of these security aspects are required. So now, if you look at on the embedded side of it, there are like four broader category of the security which you can categorize. So one is the platform communication. So when you are talking to the platform, that you need to be doing very securely. Otherwise, the platform will not be knowing that who is the guy who is to whom I'm talking. Let's, for example, if you are using a key-based system and the key was stolen, and then it is being used into the other device, right? Uh, Really, platform will not know that it is coming from a emulated device or it is coming from the real device. So that is very important of it. Of course, people use various mechanism where they has lot of the parameters from the device to make a unique key, so that you can like prevent or you can stop the let's say unwanted users or so. Some of them, they also use a fusing into the system, in the sense like there is a device where you have already burned a specific key, and then if you take the binary to the new device, that key will not match and then you will reject it. So that is another way. Device and the sensor communication, this is mostly socket kind of communication, and this typically they are handling with help of encrypting it, and then also using a key which is burnt into the these devices, so that it is more secure. Also, there are certain more checks were done in order to validate. For example, there could be some frequency, there could be some challenge sequence which device can check to the sensors, that is it the right sensors or not. Application layer security, of course, like there is a application should do various very good cooperation, as we have shown into the previous PPT, previous slide, where like if the application is not a good intended application, it may make my system down and my system will not be able to perform the right work. You must have seen in your laptop, then if something happened, or let's say some processes consume a huge amount of memory, and so then your laptop is not usable. It is just like you hanged and then you need to boot, though you are working on, let's say, Word, or let's say some Excel sheet, where like everything was proper, but due to other thing, you have to reboot it, so you are out now. Then the OT and firmware, this is like very important aspect of it, where the it need to be securely done. So if you look at the challenges in the embedded system, we're just continuing. So the embedded password is one of the challenge. I'm saying, like, when you building the device, you are embedding a password. Lack of device authentication, I can tell you that there is older devices, they are not authenticated. They are just directly connecting to the platform, and so software upgrade, like firmware, as we said already. Let's say everything is proper, but there is a physical tampering. For example, somebody has stolen your phone, and then he has, let's say, rooted it, and then you have put some vulnerables, or let's say bad application, or a service, right, without knowing to you, then what will happen, that will keep performing the data which you're not supposed to do it, right? So that is a physical thing. Outdated component, of course, like if you look at some of the devices are not upgraded now, because there's a newer version and the old specific devices were not supported. So that is also a challenge in case of Linux, mostly on the embedded side of it, where like there's outdated component. And the last thing is the device monitoring and management, which is missing. So most of the platform, if you see, they try to address the issues which we have discussed in last 2 3 slides, at least in case of the devices, where like you can make it more secure in terms of authentication, in terms of data exchange, in terms of allowing the application to run. Okay, so what we'll do now, just a minute. So as we have this covered the first two part, we will talk about, let's say, MQTT in a detail. So I hope you guys have used MQTT or have gone through the MQTT part of it. But not then also we will show you a very quick understanding of MQTT, and then we can talk about the layers where we can bring the security into it. Okay, so MQTT is nothing but this is you can just say the light-weighted communication protocol using publish subscribe as a protocol. If you see all of the our native communication, like if you look at the client server architecture, right? So we use socket, and then socket management is one of the tough activity where you need to manage the socket, you need to look for if the devices are disconnected, then you have to look for connection and so on. So all of these issues were fixed, and very additionally, one activity what was done in the case of MQTT, where the payload of the socket were reduced. So what will happen that if you look at in device side, if there is a smart bulb, right? What is the data which you want to get into the platform? Just whether the bulb is on or off. There is nothing else. There could be something more, for example, what is the power it is withdrawing and various other things, but just think like it's a one bit of data which is saying on or off, right? So for sending one bit of data, your payload is still the same if you're using a socket. So in case of MQTT, that payload is also reduced, and it is mostly designed for a remote location, let's say low power bandwidth network. Also, like it promotes small code footprint, very small amount of code, and so on. Okay, so coming back, like the key components in the publisher and subscriber is nothing but there is a broker, and then you have a publisher who is interested to publish let's say some parameters or the attributes, and same time there are guys who are basically willing to consume those attributes. So we have here publishers and subscriber, and this is typical pub sub model, if you the guy old guys can refer, or you can just assume that it is pretty simple. You have a library, and then you are looking for a book. What you do, you have a notebook where you go and write saying that I'm interested to read, let's say, MQTT book. An MQTT book is not available. What librarian will do, the moment a MQTT book is available, he will look at who all were interested and he will notify you, right? So very similar. This is a very robust, you can say, protocol which is available nowadays for in IoT. Of course, there are various other protocols we have, but one of the very simple, easy to use is this MQTT. Okay, and MQTT means how it works. So there is a broker, and what broker does, broker basically keep a list of all the guys who are subscribed for an attributes, and the moment, let's say, data for that attributes is available through a publisher, it just intimate everybody, right? That's the pretty much model of it. Where it is used in IoT, it is used everywhere in IoT. If you look at, for example, if you have a gateway, you want, let's say, your light to be turned on. You don't want to send the whole packet, you just want to use an MQTT channel to just say that turn on, and what will happen, the light will turn on, then it will just acknowledge back again through an MQTT channel saying like, hey, I have turned on, and the status is completed. Or let's say at a certain point of time there is a issue in terms of turning it on, then what will happen, that it may update that saying the turning on was not applied, so it is failed. It may do a retry and kind of thing. So it's heavily used into the most of the IoT solution. So it's not IoT, even let's say a lot of other even in case of banking, in case of let's say some of the chat servers and other places, this MQTT is being used. So anyway, I will just also show you one of the example which we have discussed, that how let's say MQTT does. So in both side, for example, from IoT gateway to the device also, but to the sensor as well, you can create an MQTT channel. But only thing is that you need to design that way. So let's say in certain cases the gateway may have couple of sensors connected through wire. So they typically use a socket, a plain socket kind of thing, and then from the gateway to the platform, they are using mix of, means MQTT for most of the commands, controls, and so. But for a heavy, large upload of data, they may be using some HTTP based, well-defined APIs. So this is what primarily that is being used. So if you look at this is a very small depiction, and the challenges over here is to secure both of these channels, right? So in case of MQTT, see, by default MQTT is open, in the sense like if you just set up a normal MQTT, anybody who know your IP, he should able to use it and should able to post the data. Those we will see that those challenges on the MQTT part of it. But I will just show you very quick a small hands-on part of it. Let me. So hope my screen is visible to you people. So okay.
Yes, sir, it is visible.
Yeah. So what I'm showing over here is that let's look at. So there is a broker. So you have to run broker, and all of these details are there. I think you can go to open source and get this source code, and then you can build it. So let's say if you run here Mosquito. So what is happening? Mosquito is running, and by default it runs on your 1883 port. And then you can have a subscriber. Let's say I'm interested to understand if there is a topic called hello. If somebody is there is a topic called there is a test topic. So if somebody is posting it into this topic, let me zoom a little bit. If somebody is posting into a topic, test topic, then I would like to see the message. And then there is a guy. Let's look at the next terminal is basically so the next terminal is basically doing a post of it. So just for simplicity, I will also let me do it from a new terminal. So I have a broker here. I have, let's say, the subscriber, and then I'm using here this screen to basically publish it. So let's say I'm just publishing a message here, hello world. What will happen if you see the hello world is appearing over there? So I can send, for example, in place of hello world, I can say that okay, my temperature is 60 degree. So what will happen? The temperature message is coming over there, but this is completely open. Like anybody who know the IP of it, for example, I can just show you here. Let's say if I have my IP address.
Sir, actually PPT is only visible to the people.
Oh, oh, sorry. Just a minute. I think let me share the whole screen. Okay, I was under impression. Okay, sorry for this. So, okay, can you see the whole screen now?
Yes, sir. Yes, sir.
Okay, so I will just disconnect and redo it. So what I said, like I just ran one mosquito broker, okay, and then I run one of the subscriber. For example, I'm interested to listen for a topic, okay, and then I have, let's say, Yeah, and then what I'm doing right now, I'm just publishing. So this is another terminal. So think like all of these terminals are two different devices. Okay. So anyway, just if you see here, what has happened, the masses which we have posted here, that has gone. For example, I may say here like let's say temperature equal to 60 degree. Okay, what is happening? The temperature is coming over there. I may say the temperature is changed to 89. The 89 message is coming. So what I was referring that this is quite open. Let's say if somebody know the IP address of this, yeah. So let's say my IP address is 5. So from as well, let's say they should able to do it in the sense. Okay, so yeah. So if you see here, I'm saying like I'm using IP address, it is coming, and then from the local machine also it is coming. So what I'm trying to tell you that this is quite open, and then anybody should be able to post it, the message. Okay. So okay, let me come back to the PPT here. Okay. So yeah, so before going to this, I will just say, so if you look at here, the one terminal is a car, which is basically, publishing the speed. And the other terminal, let's say other these terminals are a mobile app or let's say other unit, right? So they will receive the message. For example, if you see this is one of the yeah. So let's say so below is one of the terminal, and let's say I'm just posting this time. I'm just changing the topic. For example, I'm saying let's say topic is data, and then it is speed. Okay. So what will happen? And then I'm just mentioning here the speed is 100 kilometer. What is happening that this guy is not getting because he is not interested to listen for the topic speed. So let's create run one another subscriber, and then he is interested to look for data and then speed. Okay. So what will happen when this guy publish 100 kilometer or let's say 50 kilometer or whatever, he will get it. Similarly, like if let's say this guy is interested into a new topic which is temperature, let's say data and temperature. Okay, and then let's say this guy, if a guy is putting here saying like temperature is 60 degree or let's say 44, then this guy is getting 44. So it is very easy to manage, and it is scale also. So there are a lot of companies who, there's open source component is there which we call it Mosquito, which we are using it, but there are other companies who are also having a solution on top of it. They are basically using that. uh, just hold on, I think I need to put my power. So Okay. Okay, fine. So, yeah. So let's come back to the thing. So we got it. I'm saying like this is very small part of it. So now, what kind of security that, let's say, MQTT can provide, right? So first thing is a network layer of security. So one way to provide a secure and trustworthy connection. So I'm saying, like, when you as a consumer, when you use an IoT and when an industry use an IoT, these are two very different approaches. So in case of industrial IoT, if you see, everything is self-contained into their environment. They don't want that their data should be going to the public cloud, because it's a security, but same time this is also, they want to control every aspect of it. So if you see, they run their own network, and that network is fully secured. So those kind of provisions they do in order to secure it. There is also, so most of these cases are industrial IoT and generally large factories where this kind of approach is being used. Transport layer security. So TLS and SSL are certainly used. This method is secure and also better way to, do a data transmission, where like client and servers authentication is used. The last part is application layer. So there are different approaches, but one of two approaches I will tell you. So one is a username password. So what used to happen, that there is a username you need to provide. Right now, if you see this whatever we are doing, there is no username, there is no password, right? So you need to enable it. Then only with help of username password you will be allowed to connect. Otherwise, your connection will be rejected. But you understand the challenge. The challenge is manifold. Like, do all of your devices will have a username and password? Of course not. I'm saying right now, the device which we have simulated, where like we are sending the data from the current, I think then you people have missed that as well, so I will just show you. Okay. Okay, hold on. So we had okay. uh, Okay, no problem. I think I can run here. Yeah, so if you see this S demo, so S demo is nothing but this is sending the data to the platform. Sorry. If you see here, last time we have shown this one. Now let me refresh it. So you see, like, there's a n number of data which is got generated, and right now the time is 12:16. We got one data. You see here 12:16. The temperature is 12 degree. So if you see here, if here you see the last reading was 12. Okay, let it generate one more temperature, and then we'll see. So again, if you see, this client is certainly sending data using MQTT, and again in this case we have a secure way, like we have used username and password for it. But this is just a demonstration. That's the reason. Otherwise, in the real devices, this does not happen. For example, we got 45. If you see the next data coming, you see here the 45 degree has come. Okay. So what I'm trying to tell you, that the approach of username password is not scalable in terms of doing it. So generally what is done, there is a payload encryptions are used. So what payload encryption does, for example, like, you send the data, and then you have to encrypt it, and then server side there is a mechanism to decrypt it, to see that you are the right user. So there is a key also. There is a predefined key which you will be sharing first, and followed by the messages, so that like we can verify whether you are securely connected to the current system or not. Okay. So so I think we are done on the MQT side of it. Let me move very quickly to the last few more slides I have, and then we can do a follow-up. I think, how is the time we are doing? Okay, I think we have another 12-15 minutes. Okay, so this is another example. the publish message what was done earlier is now secure. Secure in the sense, you see here we are just putting here username and the password and then the rest of the data. So this is also used in case of our server. If you see, this is the way we are using it. Okay, the payload encryption I just discussed briefly, in the sense the data which is coming, that is decrypted, encrypted, and then decrypted on the server side of it. So in the last part, I will cover up this Linux container and try to show you some hands-on also on that as well. So what are this Linux container, Linux group, or let's say root or namespaces, right? So you know that nowadays Docker is quite popular. I think at least most of you must have heard about the Dockers, right? So Dockers are a way to containerize your environment. Earlier, people were using virtual machine, and virtual machine is heavy in terms of loading it, in terms of managing it. But the containers, let's say, Docker is lightweighted. Similarly, like Linux container is more lighter, where like you can bring the restrictions. So I will first go to this slide and explain you. So what are the, let's say, key aspect when we are trying to restrict the user? So we are certainly trying to do that, the resource limiting. You will only be allowed to perform, let's say, activities within your limit. So you will not be able to go above that limit. So there's a memory limit, there's a file system, various things. There is also a prioritization of the activities, there's a counting that, and then the control. So all of these are basically which like C group or Linux containers or namespaces are providing. But let me go through like so this slide, if you look at this slide, explain what is happening, that if you normal Linux machine, if you see, you are either a normal user or there is a sudo super user, right? Let's understand this thing. So when you are a super user, you have a right to do everything everywhere, whatever you want, right? And then if you're the normal user, then as a normal user, you all others users, you all have the same access rights. So what is done in case of, let's say, Linux container, there is a new rootfs which is given to you, and that is the only area which is visible to you. So you are basically jailed. Just understand that you may have, let's say, 50 rooms in your college, but let's say understand, like a visitor is only allowed to be present in the reception, right? So all the facilities of reception he can see, but he can't see that what's happening in the conference room, what's happening into the, let's say, internal meeting room, or let's say seminar room or labs and so on, right? Very similar concepts are being used in the Linux container as well. So if you should able to install this thing using ellipse group one, and like based on your flavor of Linux, this command may change, may differ, but these basically gives you all of the control to perform it. What chroot does, it basically jailed you into the small area, and then only you should able to perform the action into that. Namespaces are again a feature which is used from the Linux kernel, and then basically it partitions the kernel resources such that one set of processes see only that resource, and the other resources are not visible to him, right? So that's not being used. C group, so basically it is an abbreviation from control group, is a Linux kernel feature again that limits the account for and isolate the resources like CPU, memory, disk usage, network usage, and so on. So I will tell you that why all of these are required. Let's say I can group everything, right? For example, I can make my whole system secure, that I will not allow anybody to come in, right? The challenge is that what if you see most of the IoT platform today, they have developed their basic application at one go, but they certainly want like a large developer ecosystem should also come and develop a solution on top of that infrastructure. So very similar to, if you look at the App Store of Android or iOS, they have their very strong Linux or flavored, or let's say Darwin flavor OSs, but they want to allow third party to develop so that they can monetize, they can earn, they can also have a variety of application, right? Very similar challenges are also there in case of IoT. I'm saying a company developing a bulb can do, let's say, some basic thing, but certainly a company who want to do a power consumption, or let's say power saving, he may wants to optimize in a various pieces of it. So there are different angles of the application that can be built. So if you restrict him fully, they will not be allowed. If so, you want to allow him, but you want to allow him in a restricted way, or using a dbus kind of communication through which, like, you can exchange the data and so on. So yeah, resource limiting, another thing. I think I can just show you very small. I can just make one of this thing, and I will show you how it all works. Let me. So I will first show you. Let's say, if you, because this does not exist. If you see, there are certain um, uh, certain files are already present over here. Let me just go and create this. If you see, there's a cert folder got created here. Okay, so what is happening here? If you see, there is a all, like, there is a memory limit. For example, there is a memory limit in bytes. So you just think like this is a new group I've created as a cert, and then I'm just saying that, hey, your process will only be allowed, let's say, n number of bytes. So what will happen? The process which is running inside cert will not cross that. So there is various thing like out of memory control, like what all we need to handle and other things. So all of these are basically being used. So I think, means you can certainly look at, you can, like, number of bytes by default. If you see, this will be some numbers. Okay, so some numbers, so that you can limit it. For example, you can just go and say, so now if you see, if you do a cat, so this is again like your page size. So based on page size, it will just see the closure thing, and then it will show you. So now any process which you will run will basically limit to this one. So primarily, if you see, this is being used in case of Linux container, and then like how to add somebody into that. So that also you can do. If you have a process, you can just get the process ID of that, and then you can, let's, for example, we can write one hello dot this one. So if you just see that. So see, this is running. I'm saying hello world. So I've just run in background. I can just, like, look at. So this is the process ID, and this is the process ID of it. Okay, so so basically, yeah. So we just move it inside that, and so you see here, it has just cannot fork, and it is coming down. So due to that, basically, it is getting killed over here. Yeah, so I'm just putting this guy again. So yeah, so you see, this is happening because we have limited him the memory, and then the memory consumption is going high, so it is being killed. So this is the way you can do it. So I think I'm just let me go through. Yeah. So primarily, if you see, yeah, most of the thing which I've covered over here, I think. Let me once again talk a little bit about. Yeah. So we will spend some time here, but let's say coming back on this platform part of it. If you see, like this is a real time where like all of the data which is being generated is ingested over here, and if you see, what is important here is the key management. So these are like the secure keys through which this communication is happening. Without that keys, you will not be allowed to communicate with the platform. So the security aspect of it is there, and of course, like I can just show you. Yeah, so there are certain rules which you can set here. For example, you can just say that on the smart plug and the specific device, for example cert device, if let's say temperature of this goes beyond, it's get updated to, let's say, if greater than 60 degree or 45 degree, then send alert, let's say high temp and a mail to it. So if you see here is the high temperature. So when the time this temperature goes above 45, it basically send a mail to the registered user, kind of thing. Okay. Now again, like if you look at on the end user perspective, or let's say organization perspective, again, this security is very important part of it. I will also talk about here is the software management. For example, if you have a new package, let's say I'm just saying there is a OS, and then you have version, let's say 1.0, and so what will happen when this kind of packages goes to the end user? At that point of time also, there is a security key which is basically being verified. It's typically there's a checksum and then the key. So through checksum they verify that the package which has come is a proper, and then through the specific key they decrypt the data and then they apply it. So overall, if you see, this is an example of IoT platform where like all of these things are happening, and same time, what I've demonstrated you is the uh, different area in which the security is required. So this is the area which we mostly not covered. It is more like a socket programming. So here, if you see, this is a gateway which is talking using a MQTT is being covered. Then we have also covered, let's say, certain consideration on these boxes when on the gateway when the applications are sitting, like there is a containers on which they can be sandbox, and same time there's a platform. On that platform side, what are the different approaches people take? For example, as we talk about the application layer security, we discuss about the access layer security, like DMG zone and others thing, right? So all of those are quite important. In case of ERP and other, there is also OAuth is quite being used nowadays. Hope, I think in your web and other security, people must have covered those things in more details. So I think that's all from my side. I'm saying this is what is the different buckets of the security activity. So now I'm open for the question, or let's say feedback if you have. If somebody has sum it up, fine. Otherwise, if you would like to know something, means I'm open right now. So you is that somebody means do you have some feedback or some of the question or anything? I'm saying the organizers as well as like yeah. So I think chat here.
If anybody
I think chat
want
box.
to ask some questions, or if anybody have some queries, you can ask. Kindly unmute your mic and ask.
Sir, we have a question from Uma Patil. Sir, are there any simulation tools to test for access security?
For as access
For
security,
access, yes. Yeah, access, yes.
access or assets.
Sir, access.
Okay. Yeah. So see, so typically there are certain tools which are available. Means you can say these are, for example, when you see in some of these you need to configure, but in certain companies or organization they have certain tool to verify it, where like the access is only happening through the authorized IPs, or let's say authorized user, with help of so one thing is very openly, let's say VPN is being used, but other than that, they configure a machine. They typically call them as a jump servers, and then through that jump servers, you log in, and then only you should able to do a hope, next hope to the required servers.
Uh, Anyone who wants to ask any question from sir? Sir, myself, Abhigyan Tiwari from Sage Group. Sir, I want to know that about MQTT. So,
Yeah.
as we know that MQTT, the broker is the backbone of that MQTT, and
Mhm.
still it is not acceptable by IIoT, sir. So, industrial IoT is not working with that MQTT.
Yeah. So
Sir, what will?
yeah, go ahead.
Yes, sir,
Go ahead,
please.
sir. Yeah,
No,
so
sir,
I'm
please, sir,
saying,
please.
yeah, so industrial IoT, typically they call it that OPC, like OPC servers, and then they use a WebSocket or a more large stream. So I will just tell you that the background of these two. So if you look at the industrial use case, right? So industrial use case, just understand, if you're your institutes or your home, if your institute, if you have to embed, let's say, sensor in every classroom, or let's say your gate and others, probably it will be few hundreds, maybe 500 as a maximum sensors which you have. But just think about industrial IoT use case. I can just show you, means I can just share you one thing. Hold on, I think so. I can just show you. This is a BPCL um, energy plant in Kochi. So just look at the amount of data they have. What I'm trying to tell you, that they have 80,000, 50,000 to 80,000 data point per minute, you can say, or per second, you can say. You see the number of the nodes, means number of the sensors are very, very high. You got right. So that's the reason they believe in more dedicated communication than using this client socket, because there is a limitation, you understand. When you are creating this is nothing but a new socket only which you are opening, and when
Yes, sir, yes.
the data chunks is this high, I'm just, you see like this one sheet I'm showing you, and you see like there's a huge list of nodes are here, you see, right? And similarly, like if you look at all of these nodes, it's same, and then you see like this is 1 hour data, like at 1 a.m., at 2 a.m., at 3 a.m., and so on. But it's a huge in number. That's the pretty reason that they don't go for it. But it is very good fitted for all of the use cases, right? And then of course there is a scale they are doing with help of multiplying the instances of the MQTT broker. Hope I answer your question.
Yes, sir. Thank you. Thank you so much, sir.
Okay. Uh,
Yes,
yeah.
anybody else have any queries? The queries are, I think, sir, your session was self-explanatory, and I want to thank you on
Thank.
behalf of the RGPV TechUp 3 section and the Department of Computer Science and Engineering SIRTS, the SAGE Group. Your session was really nice, sir. It is very informative. Thank you, sir, for accepting our invitation and delivered such a nice lecture. Thank you very much, sir. And I would also like to extend my thanks to all the participants who joined us and take advantage of this faculty development program. I hope this will help you in your future. Thank you, sir. Thank you very much.
Yeah, thank you. So, in case if somebody are looking for more information and so, then I have my slide projected here. I think they can note down the email IDs, and if they have any, they would like to also explore IoT platform, they can reach out. We can also enable the platform for them.
So kindly share your that information slide.
Yeah, so it is. I'm just projecting it, or. Okay, I think it's your. Can you see my? Okay, I think right now my screens are not shared. So hold on. Can you enable the sharing for now, or how is that?
Yes, yes.
Okay, so yeah, so I was just showing this one. I think in case if they're looking, this is the email ID and
Yes, sir. Now it's visible. Yeah.
okay, yeah. Fine. So I think it was really nice also for me to take this session. Typically, it's more IoT platform we cover, but because you had a security part of it, so uh, I have added a couple of slides over there. But yeah, there is a lot of hands-on material that I think in future we can look at how to extend it. Okay.
Feedback link is given to the chat box itself. So every participant can fill that feedback come attendance form from the chat box. Link is shared. You can see that link is already shared. Okay.
Yeah.
So
So
thank you so much,
also
sir.
yeah, also you share me the feedback
Yes.
if there's anything, yeah, I can work and can improve on that.
Okay. Okay, sir. Sure, sir.
Okay,
Okay.
thank you.
Thanks a lot.
Thanks,
Okay,
guys. Thank you.
sir.